Hello all. Okay, let's talk about engine construction. Okay, this is chapter 4 now. Okay, so we will focus on the piston engine. Of course, that's the engine that we use in almost every car on the street now. Okay, so there are two type of piston engines. Okay, the first one is SI engine, spark ignition engine. The second one is diesel engine or CI engine or compressed ignition engines. Okay, both of them are similar in construction. They have the same components in the car. Okay, main components, okay, for both of them are cylinder blocks, cylinder head, crankshaft, bearings, pistons, connecting rods, and valve trains. Okay, if translate into Thai a little bit. Okay, cylinder block. Okay, in Thai we call เสื้อสูบ okay, or เสื้อเครื่อง okay, cylinder head. Okay, we call ฝาสูบ in Thai. Okay, crankshaft is เผาข้อเหวี่ยง okay, bearing is bearing. Okay, or sometimes they call shaft in Thai shaft. Okay, piston is called ลูกสูบ okay, connecting rod is ก้านสูบ okay, and valve train ก็คือกลไก valve. Okay, so the main difference between SI and CI engine is that normally compare part to part, let's say piston and piston, connecting rod and connecting rod. Okay, gasoline connecting rod and diesel connecting rod. Okay, the diesel one are usually heavier and stronger. Okay, of course, because for diesel we compress a lot, so the pressure inside the cylinder or pressure inside the combustion chamber is a lot higher than benzene engine. Okay, and then gasoline engines. Okay, so it's a lot stronger because internal pressure are a lot higher because compression ratio is a lot for diesel. Okay, so let's talk about each of the components of the engine. So the first one is cylinder block. A cylinder block is basically the foundation of the engine. Other component will be attached to the cylinder block. Okay, this is a picture of a cylinder block. Of course, you have cylinder. Okay, this is four cylinders, so you have these four holes or four cylinders inside. Okay, and it has like a hole to attach other things, right? This hole, okay, this part to attach other things. So basically, most blocks are cast from iron, okay, cast iron, okay, or iron mixed with other metals such as nickel or chromium. So is alloy. Okay, some block are cast from aluminum alloy. Okay, so because it's cast, okay, it comes from casting process, so the surface of the engine is not smooth, it's not shiny. Okay, it's going to be a little bit rough on the outside of the cylinder block. Okay, however, if you want to attach anything, okay, if you need to attach anything, you have to machine, okay, that section so that it can attach to others. So it had to be smooth and shiny, okay, so that anything that pass through this section is not leak outside. Okay, so this is our the cylinders. Okay, now inside this block, around the cylinder is not a solid block. Okay, around these cylinders, okay, we also have this water jacket. Remember, most of the engines are liquid cool. So the liquid or water has to go around the cylinders to remove heat. Okay, so the thing that we cannot see, okay, between the outside surface of the engine and the cylinder well, is the water jacket. Okay, it has the passage of water. inside this engine block. Okay, this is a picture of three cylinder cut in half. So it's sectioned in half so that you can see the water jacket inside. Okay, this water jacket is made, okay, during the casting process. Okay, normally before you cast, you have to have a mold, right? You have to have a mold, engines mold. Okay, before you put the mold together, okay, you have to make a sand. Okay, you have to build a sand. Okay, so that it becomes shape of this water jacket, and then you put this water jacket model. Okay, the model of water jacket. Okay, that's made with sand. Okay, you put this sand inside the mold, and then you close the mold, and then you pour in aluminum, melted aluminum or the melted cast iron, right? And then you wait until it cool down and you get the engine block like that. Okay, after that, you have to remove the sand so that you get water jacket inside. Okay, to remove the sand on the side of the engine, okay, we always have this hole, this big hole on the side of the engine, or these two, this one and that one. Okay, those are called core clean out holes. Okay, it used to clean out the core, so it used to remove the sand from the process, from the casting process, so that we remove the sand and we get water jacket. Okay, and then we're gonna close this core. Okay, this hole is gonna be closed with the sheet metal. Okay, this cap. Okay, they have this cap. Okay, and close the whole thing. Okay, and then we will never open that hole. Okay, unless we want to clean the water jacket inside. But normally we do not open that hole anymore. Okay, so that's the engine block. Okay, so it's made of cast iron or aluminum alloy. Okay, the manufacturing process is casting. Okay, it has cylinder, it has water jacket, it has core clean out. Okay, it also have other machining section to attach other things. Let's say this is for attach of the crankshaft bearing here. Okay, these holes. Okay, some of the hole is used to bolt the cylinder head. Okay, some hole is used for oil. Okay, the lubricating oil. Some holes is used for water, the cooling water or the coolant. Okay, now if you make cylinder block using aluminum, okay, you have to be careful because uh, aluminum is not as strong as iron, as cast iron. Okay, but aluminum has good properties. Aluminum weight much less than cast iron, and it conduct heat better than cast iron. Okay, however, okay, the drawback of aluminum is it is too soft to use as a cylinder wall. Okay, because for cylinder wall you have piston moving inside, and you have the piston ring. Okay, attached to the piston to seal. So piston ring scratch the cylinder all the time. Okay, it move on the cylinders. Okay, therefore we have to have a strong cylinder wall. Okay, therefore, okay, if you want to use aluminum block, okay, you either have to use cast iron cylinder liners. Liners look like that. Okay, to use as a cylinder wall. Okay, or you have to cast aluminum alloy with silicon particles. Okay, so the first option is to use liner, of course. Okay, you put liner there and the piston move inside the liner, so it doesn't cause any problem. It's moved inside the cast iron cylinders. Okay, but the rest of the cylinder block can be made from aluminum. Okay, now this liner also have many types. Okay, you can have cast in liner, Okay, so you put the liner during the casting process when you make the cylinder block. Okay, or you can press in. Okay, you can press in later. So cast the aluminum cylinder block, and then push the cylinder liner later. Okay, you can do both of them. Okay, both, there's two choice. Okay, the liners also have, also can be dry liners, which mean that this liner do not touch the cooling water. Wet liner, okay, it is exposed to the water jacket or to the cooling water. Okay, also dry liner is looks like this. Okay, it is backed with the engine block itself. Okay, but this liner, okay, is backed by the water jacket. So comparing the two, okay, this one can be thinner, okay, because the back side of it is solid, right? This one has to be thick because the back side is water. It cannot help you pushing because inside the cylinder has high pressure, right? Okay, our wet liner can leak, right? So you have to have a good seal on the top and on the bottom because it can leak. Okay, dry liner cannot leak. Okay, water cannot leak through this liner. Okay, however, okay, when we talk about the heat transfer, okay, when we want to remove heat from the cylinder, okay, wet liner can remove heat a lot better than dry liners because it touch water, right? So water can come and pick up heat here. Okay, so that's good and bad for dry liners and wet liners. Okay, now that's the first option. The second option is using aluminum alloy containing silicon particles. Okay, this is what it looks like. Okay, so aluminum alloy, okay, when you have molten aluminum alloy, okay, you put some silicon particle there. Okay, silicon is made from sand, which means it is very strong. Okay, it's like stone, right? So you put a powder of silicon in the liquid aluminum alloy before you pour into the mold. And then after that, when the cylinder are honed, so when you drill the cylinders, okay, to the final size, and then it is treated with some chemical that eats away the aluminum surface. So this is a cylinder wall. Okay, after you make a cylinders and then you put some chemical there, okay, to eat away this aluminum. So just a little bit. Now, when the piston move up and down, it doesn't move up and down, or it doesn't scratch the aluminum. It scratch this silicon particle. Okay, it's very strong, right? So uh, it doesn't have problem, okay, with the piston. And then the other benefit of using this silicon particle is that the surface area of the frictional surface area, the surface that causes friction, is less because we have aluminum there and we have silicon there. Okay, only this surface is creating friction inside the engine, so you have less friction using this aluminum block with silicon particles. So that's the two options. Now, the next component is cylinder head. Okay, this is a picture of V engines. Okay, V8 engines. Okay, for V engine you have two cylinder head. The one on the left bank, the one on the right bank. Okay, two heads. This is another picture of the cylinder head. Okay, basically the cylinder head is the part that control the operation of the engines. Okay, it has valves. These valves, intake valve and exhaust valve, are installed inside the cylinder head. Okay, intake, okay, the air and fuel flow in through this cylinder head. So these are the port that intake. Okay, let's say this is exhaust manifold. So the other side, okay, are the port that intake air and fuel mixture. Okay, that air and fuel mixture come from this intake manifold, and then the exhaust go out through this cylinder head. Okay, exhaust port inside the cylinder head and go out through this exhaust manifold. What else? Okay, it also have the valve trains mechanism on this cylinder head. Okay, that control the valves. So most of the engine control. Okay, air fuel mixtures going in, exhaust going out. Okay, the valve opens. Okay, are controlled inside this cylinder head. Okay, so up here, okay, on top of the cylinder head has valve trains. It is we install the valve trains on top here. Okay, valve train need lubrications, so we have to put lubricating oil there because the camshaft is moving, the valve is moving, right? So we have to put the lubrication oil, okay, circulate the lubricating oil there. Okay, therefore we have to have a cover. Okay, this is called valve cover. Cylinder head has valve. This is valve cover. Okay, and on the valve cover you have the oil filler cap that you can fill in the oil. Okay, the lubricating oil is filled through this cap. Okay, on the valve cover on the top of the cylinder head. Okay, so those are cylinder head. Okay, it is made from the same material as the cylinder block. Okay, it is cast from cast iron or aluminum alloy. Normally they have to be the same materials because the expansion is the same. Okay, during when it's heat up, when the temperature increase, we want expansions coefficients on the of the cylinder head and cylinder block to be the same, so that it's expand at the same rate, right? Uh, Basically, this cylinder head, okay, create the top portions of the combustion chamber. Okay, so here this is a cylinder block. You see, this is water jacket, and the piston move in the cylinder block. Okay, the cylinder head is this part. It creates the combustion chamber here. Okay, there are like this is wedge type combustion chamber. This is a hemisphere type combustion chamber. This is a pen roof. It's like a roof like that. And this is a cup combustion chamber. So for benzene, for gasoline engines, okay, you can find this wedge type, okay, in some old engines that have like one intake and one exhaust valve. Okay, this one is hemisphere type when you have two valves on the different side. And this is a most modern car has pen roof because you have four valves. You have two exhaust and two intake valves. Okay, and this is used in diesel engine. Normally in diesel engines, the combustion chamber is inside the piston. Okay, they do that. Okay, they decide like that because when they inject diesel, they want the diesel fuel like injection. Okay, the spray of diesel fuel to be to create a swirl of air and fuel. Okay, not just fuel, to create a swirl of air and fuel inside the combustion chamber for diesel. The next component is crankshaft. Okay, crankshaft look like this. So basically, it is a shaft, and it has crank. The crank that offset from the shaft. Okay, so that's the shaft. That's crank, 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 crank. Okay, sometimes we call it crank pin, crank pin. Okay, crank pin offset. Okay, we use this offset or crank. Okay, to connect to the connecting rod, connect to the pistons. Okay, so that we can transform the reciprocating motion into rotary motions. Okay, so that's we need to do it. Okay, we have to have this cranked. Okay, so this crankshaft and crank pin. Okay, so the front of the crankshaft is normally connected to the pulley. Okay, this one is to drive other components. Okay, the back side of the crankshaft is connecting to the flywheel. Okay, that drive the car. Okay, that send power to drive the car. Okay, this crankshaft is the one that making power in the engines. Okay, it's the main part of the engines. So it is made from basically normally it is made from forging. Okay, the forging process. Okay, of heat-treated alloy steel. Okay, uh, casting is not popular. Okay, casting is because this crankshaft will have to uh, withstand okay a lot of uh, power stroke, a lot of shock from the power stroke. Okay, a lot of torsional shock from the power stroke. Okay, therefore, normally it is created by forging because forging create a stronger parts, a stronger product. Okay, therefore, mostly forging. Okay, the as I said, crankshaft convert reciprocating motion into rotary motions. Okay, it has to be subjected by torsional and bending stress. Okay, because we have cranked on one side. Okay, we have to put weight on the other side. Okay, this part is called web or counterweight. Okay, counterweight is placed on the opposite side of the crank pin. Okay, to balance the shaft. Okay, you put like 2 kilogram here and you have to put 2 kilogram there. Okay, just the same, just to balance the shaft. Okay, if your mass is not balanced, it means when it spin, it's gonna shake, right? So we have to balance the shaft. So that's the function of those counterweights. One, two, three, four. Okay, the output connect to the flywheel. Okay, so that's the crankshaft. Now, to put the engine together, okay, put the parts together. Okay, normally you first put the crankshaft and the bearing. Okay, this bearing, crankshaft, and bearing on this part of the cylinder block, on the bottom of the cylinder block. In fact, normally when they assemble this engine, they have to flip the engine upside down so that they can put the crankshaft from the top. A lot easier to assemble the engine. Okay, and then you have bearing there. The okay bearing has two sides, two part or two pieces. Okay, one piece there, one piece there, and you have the bearing cap. Okay, and then you connect the front part. Okay, with the seal. Okay, this uh, in this engine. Okay, the crankshaft also drive the pump here, the oil pump. Okay, on the back you connect to the flywheel. Okay, they do this and then they flip the engine back, and then okay, they put this piston and connecting rod from the top. Okay, you have to put the ring on the piston first, and then you have to squeeze the ring. Okay, you have to squeeze the ring, and then you hit it. Okay, down into this cylinders. Okay, because normally the ring is compressed inside, so you have to compress the ring and then put them in. Okay, you have to connect this, I mean this set together first. Okay, the ring, the piston pin, and the connecting rod together. Okay, and you put it down there, and then connect to the crankshaft. Okay, after you put this connecting rod, you connect the crankshaft using this rod cap. Okay, rod cap and connecting rod. Okay, connect together using this bolt, the two bolts on each side. Okay, and then you assembly the cylinder head on the cylinder head. So you put the valves from the bottom, you put the camshaft there, you put the rocker arm there, and then you No, you haven't put the valve cover yet. Okay, put the head on the top of the cylinder block. Okay, and that's it, right? The next component. Okay, you can find a lot of YouTube. Okay, that's show how engine is assembly together. Okay, in a video so that you can understand more how the engine is assembled. Okay, so then the next part is exhaust manifold. Exhaust manifold is basically a set of tubes, here tubes that carry exhaust gas from the cylinder head, okay, that's coming out from the cylinder head to the exhaust system. Okay, we have the exhaust treatment system. Okay, the exhaust coming from the engine is go to the tailpipe of the car, right? So those are exhaust system. Okay, so this engine has intake manifold and exhaust manifold on one side, on the same side of the engines. Okay, this is exhaust port. Okay, this little one are the exhaust port. This is probably 1, 2, 3, 4, 5, 6 cylinder engine. So the exhaust combine in the exhaust manifold and go out. Okay, so that's exhaust manifold. Okay, intake manifold is on the other side. Okay, intake manifold, okay, similar to the exhaust manifold, is a set of tubes that carry air or air and fuel, okay, from the throttle valve to the intake port of the cylinder head. Okay, those are the intake port in the cylinder head. Okay, this is the exhaust manifold, intake manifold. So the air coming here through the throttle body to the throttle valve. Okay, we're gonna talk about that. Where the throttle valve and air go through this intake manifold and it go into the engine. Okay, you can mix fuel here, or you can mix fuel there. Okay, you can inject the fuel there. Okay, if you inject the fuel there, it means that inside the intake manifold only contain air. Okay, if you inject fuel here, it means that inside the intake manifold is the mixture. Okay, the difference is that the mixture can burn. Okay, but air cannot burn. Okay, therefore, uh, the design of the intake manifold might be different. Okay, this is intake manifold of V engines. Okay, normally for V engine you have exhaust on the side of the engine, and then you have the intake in the middle of the engine because exhaust has to go down under the car to the exhaust system, right? Okay, on top is a intake manifold. Okay, you can see this intake manifold is made from plastic. Okay, engine also have a lot of bearings. Okay, this show you that there are many bearings. Anything that can spin inside the engine has need bearings. With the main bearing for the crankshaft, the bearing for the crankshaft, for the camshaft. Okay, and bearing for water pump, bearing for the fan, bearing for many things. Right? Okay, but the important one is the main bearing. Okay, the crankshaft bearing. Okay, the crankshaft and connecting rod bearing. Okay, looks like that. Okay, this is called main bearing. It is used to support the crankshaft here, here, here. Okay, so they are separated into two pieces, this piece and this piece, always like that. Okay, it has a groove, oil groove in the middle. Okay, like that. Okay, some of them has this flange. Okay, to limit. Okay, to support the movement along the shaft, along the axle of the shaft. Okay, or you can have thrust washer there. Okay, most of the bearing looks like that. Okay, there is one bearing. Okay, that need to have flange, or you can have just a regular bearing with this thrust washer here to limit the movement of the shaft. Okay, or it's just written there. Okay. Now, how do you lubricate the crankshaft? Okay, normally, okay, this is the shaft, this is the bearing. Okay, normally we have a gap, a space between the shaft and the bearing. Okay, that is called oil clearance. Okay, oil clearance. Okay, we'll fill in this space. Okay, so that's how engine is lubricated. Okay, we're gonna talk more about this when we talk about lubricating system. Okay, therefore you have oil hole, you have oil groove, okay, such that you can inject the oil, okay, lubricating oil inside the bearing, okay, and this how the oil is circulate. Okay, you have oil pump that pump the oil inside, and the oil is injected into the bearing like that. Okay, so that's how the lubricating system works. Okay, let's come to the next component. Okay, the connecting rod. Okay, the connecting rod is a link between piston and the crankshaft or the crank pin. Okay, it converts reciprocating motion into rotary motions. Okay, now the connecting rod is connected to the piston using this piston pin. Okay, you can press fit, so the connecting rod and the pin is pressed fit like that, so they fit together. Okay, or it's free floating, so it doesn't fit there. Okay, but you have to have this snap ring, okay, such that you can limit the movement of the piston pin. Okay, now connecting rod is separated into two parts or two pieces. Okay, the connecting rod itself and the connecting rod cap. Okay, during manufacturing, okay, they have to be made together. Okay, during manufacturing, rod cap and rod are both together before they machine the inside of this. And then after it is used in the engine, okay, whenever you have to dis dis disassemble the engine, okay, and then put them together, you have to maintain the pairs of the connecting rod and connecting rod cap. Okay, because after you use engine for some time, okay, this bore, okay, this bore, okay, gonna shape differently. Okay, it's gonna wear, okay, and then we want to put them, I mean, together using the same pairs. Okay, the next component is piston. Okay, we have a lot of components inside the engine. Okay, the next component is pistons. Okay, piston has three functions. The first one is it forms a movable wall of the combustion chamber. Okay, the side of the combustion chamber is the engine block. The top of the combustion chamber is the engine head, okay, or cylinder head. Okay, the bottom part of the combustion chamber is the piston. Okay, and it has to move like that. So the top of the piston has to be very hot and has a lot of pressure, right? Okay, so that's the pistons. Okay, then it transmits the turning force to the crankshaft bar through the connecting rod. The third function is that it transmits side thrust, okay, which is due to the angularity of the connecting rod to the cylinder walls. Okay, the piston, okay, normally the piston is here. You have the pressure pushing the piston down, and then the connecting rod sometimes is go in this direction, sometimes it's in this direction. So the the connecting rod can tilt, right? Can tilt forward and backward. So this is the change in the angularity of the connecting rod. Okay, when the connecting rod is pushing the piston this way, piston is pushed this way. When the connecting rod is this way, the piston is pushed this way. So piston has to transfer this thrust into the, to the cylinder walls. Okay. Therefore, piston has to have these properties. First is it has to be strong enough to withstand high pressure from the combustion. It has to be strong. Second, it has to be very light because it has to move fast. Okay, to minimize inertia force, or to minimize the inertia. Okay, when you can minimize the inertia, it moves faster. Light piston permits higher speed of the crank of the engine. Okay, when you crank or your engine has higher speed, you have you have high power, you have more power. Then the piston has to be good conductor of heat. Okay, because we want to remove heat from the combustion chamber. If the top of the piston is still hot, it means that in the next cycle, okay, when the fuel and air go in, it can burn because the piston is too hot. Right? The piston has high temperatures. It can burn air and fuel. That's called detonations. Okay, so it have to remove heat fast to suppress detonations. Okay, so remove detonation or reduce detonations or prevent detonations. Okay, and allow higher compression ratios. Okay, so those are the properties that we want from pistons. Okay, therefore, it is made of aluminum alloy. It's strong, it is light, and then it conduct heat very good. Okay, aluminum can conduct heat very good, right? And the design of the piston is normally full slipper piston. Okay, that's the name of the design of the piston. The piston is shaped like that. Okay, this is called full slipper. Right, this is the top of the piston. You can design the piston head. Okay, to support the combustion chamber. Okay, you have to have groups. Okay, for the combustion rings and oil rings. Right, you also have to have a hole for piston pin, and then you have skirt on the left and on the right, on the front and on the back of the pistons. Okay, and you need this space here, okay, this curve of the piston. Okay, this curve is basically used to prevent crashing with the counterweight. Okay, this clearance is prevent crashing between the counterweight and the piston itself. Okay, therefore the piston looks like this. Okay, this is a face, okay, that hit the cylinder wall. Okay, this is another face that also hit the cylinder wall, that's riding on the cylinder walls. Okay, the head of the piston can be different. Alright, it can be flat head, dome head, concave, and recess. That's just a name. Okay, piston can be forged. Forged or cast. Okay, cast piston mean you cast. Okay, you made by pouring molten aluminum into molds. Okay, forged piston mean you press. Okay, first you heat the aluminum, but you don't melt it. Okay, you heat the aluminums. Okay, such that it become red and soft, and then you put that into a mold, and then you hit it hard. Okay, you press it hard so that it becomes shaped like that. Okay, into piston shape. Both of them are heat treated. Okay, to make it stronger. Okay, normally forging process is better than casting process, because casting process you already make it into liquid aluminum, right? Molten aluminum, which mean air can get inside, air bubble can get inside. Okay, but forged piston, okay, you don't melt aluminum, right? So it means that air cannot get in. Okay, however, to do that you have to heat the whole piece of aluminum, okay, so that it has the same temperatures, okay, which is difficult. Okay, you have to use electricity to do that. Okay, not some burning or some fuel burn or some the the oven to do that. You cannot use that. Okay, so forged piston are denser because it has less bubble. It's stronger. Okay, it has a better heat path. It can conduct heat better. Okay, this is a picture of the operating temperature of cast and forged piston. Okay, just compare at the same location. Let's say this is this location. Okay, cast is 177, but forged is 149. Okay, this one remove heat a lot better than cast piston. Now, the size of piston has to be smaller than the cylinder because otherwise piston cannot move. Okay, it has to be a little bit smaller than the cylinders. Okay, so that's called piston clearance. Okay, these are the piston clearance. The clearance is normally 0.02525 micron or about 0.12 millimeters. Okay, that's around this. Uh, this is this number. So that's very small. Okay, so that's very small. Okay, normally oil fill the clearance. Okay, normally when engines run, if you have too small clearance, it means too much friction. Okay, small clearance means large friction. Okay, so you lost a power from high friction and you have a lot of wear, of course. If you have large clearance, you're gonna have piston slap. Okay, piston slap means the sound made from the engines, like something hitting other. Okay, that's because when you have too much large clearance, piston gonna move. Okay, when the connector rod change directions, when the connector rod change direction, piston gonna move from the left to the right like that, and then hit the cylinder wall, and then go back and hit this way, hit this way. Whenever the connector rod change the right directions, change the angle, the piston gonna hit the cylinder wall. Okay, and this hitting create noise, and that noise is piston slap. Okay, it's like clicking noise. It's a hitting noise from the engine. Okay, when the engine run at idle, so you get how do you call slower slapping. Okay, slower piston slap, and then when engine is like rev and high RPM is faster. Okay, now because we don't want this piston to stuck inside the cylinder, okay, we have to have some expansion control. Okay, we need that because normally aluminum pistons expand more than cast iron cylinder wall. We use cast iron for cylinder wall, but we use aluminum for piston. Okay, when it heats, when the temperature rise, the material expand, right? And aluminum expand more. Okay, which means that sometimes if it expand too much, it gonna stuck. Okay, you're gonna lost the clearance, and then it gonna stuck inside the cylinder. So the expansion must be controlled. Okay, to control piston expansions, first you can increase the thickness of the metal in the head. Okay, this helps because you can remove the heat faster. Okay, aluminum is good conductor, so you can remove heat if you have thick head, right? You can have campground pistons. Okay, campground mean okay the piston is machining such that it is oval, not circle. Okay, not circle, it's oval. Okay, because we know that okay this is a pinhole side. Okay, the pinhole side, and this is other side. Okay, okay. When you have thinner material there, it's gonna expand more. Right? It's gonna stretch more. Okay, which means that A gonna stretch more than B. So normally when we make piston, we make it into oval. Okay, we make B more than A. so that when it heats up, A expand or A stretch more, and then it becomes circle at normal operating temperatures. Okay, you can also do the barrel shape. Okay, this barrel shape. So we know that the on the top is like the temperature is more than the bottom, so we taper it a little bit, right? We call it barrel shape, which means that this part is smaller than this part. Okay, because this one is hotter. When it expand, it become the same, right? And you can also use steel strut cast into the piston, because we know steel is do not expand as much as aluminum. So we cast the belt or the ring of steel inside the piston, so that it prevent the piston from expand. Okay, so those are the techniques of to control the expansion of pistons that they use in car engines. Okay, piston also need to have this piston pin offset, the offset. Okay, the offset is just here, piston pin offset. It is the distance between the center of the piston and the center of the piston pin. Okay, you have a little bit of offset there. Okay, this offset is used to minimize piston slap. Remember, piston slap is when piston hit the center wall, hit this way and hit this way and hit this way, right? Because connecting rod change directions, right? It hit this way. Now, when you have this offset, instead of piston like uh, when piston move up, instead of it touching this wall and then it move down touching this wall, right? It go up this way, it go up this way. Now it's tilt a little bit because you have this offset. This offset create a little moment because the force coming from the chamber is in the middle of the pistons. The force from the connecting rod acts at the center of the piston pin. So these two force create a little moment, a little torque, a little moment to tilt the pistons up and down like that. So you can minimize piston slap because, okay, piston gonna uh, touch this wall on one corner and touch this wall on the other corner, just like that. Okay. Now piston also uh, need to have, or some piston, high performance pistons, okay, will have top ring groove fortifications, which mean that a cast iron ring is cast into the piston at this piston ring groove. Okay, top ring groove. Okay, the ring groove has metal inside. Because when piston move up and down, the piston ring hit the groove. Okay, when it go down, it hit up. When it go up, it hit down. Okay, the ring hit the piston, and then the groove is wear fast. Therefore, instead of using aluminum, they put the ring, the cast iron ring there, because it's stronger than aluminum, right? And some piston also have silicon particle in it. The same thing as when we talk about the cylinder block, the engine block, right? It has a silicon particle in it, right? So it can be low frictions. Okay, they even use it in motorcycle now. Okay, some motorcycle uses silicon piston. Yeah. Now the piston rings. Okay, uh, the piston rings have two types. Right? The first one is compression rings. The other one is oil control ring. Okay, they have different functions. Okay, basically it is. I mean, both of them, okay, are larger in diameter than the cylinders. Okay, the ring is normally larger. but it has this gap, ring and gap. Okay, normally after install, it is compressed for installations. Okay, with almost closest ring gap, so you close it. Okay, normally it's larger than the cylinder. Okay, but you have to compress it. Okay, the top two, normally the top two one are the compression ring. The top compression ring, the intermediate compression ring. Okay, and the third one, okay, the last one is oil ring. Okay, in this picture there are three pieces oil ring, so it has three pieces combined together to become oil ring. So the compression rings function is seal compressions and seal compressions and during the compressed stroke and combustion pressure during power stroke. They are usually made of cast iron, of course. It has various shape. Okay, most of the shape, okay, try to push the piston ring out. Okay, use the pressure inside the cylinder to push the piston ring outward. Okay, outward. Okay, such that it seals better. Uh, Normally we need top compression ring and lower compression rings. Okay, when you install, okay, this two ring, because we want to seal, normally we have to turn the ring gap to the opposite side like that, such that to prevent leakage of the pressure inside the combustion chamber. Now, one thing about the compression ring is that sometimes if it cannot withstand temperatures, it can cause scuff wear. Okay, when it is operated at high temperatures, well, it is possible that the metal surface of the top compression ring, okay, can develop hot spot with just a moment weld between ring and the wall. Okay, when the piston moves to the top, it weld to the top because it stopped a little bit, right, at top dead center. When it is very hot, the ring melt and it's weld to the cylinder wall. This weld, okay, this little metal piece, okay, break, then it create rough and scrap spot on the surface of the cylinder wall. So basically, when it go to the top dead center, if it cannot withstand high temperatures, it melt. Now the piston go down, and this melted iron, cast iron, okay, after that it's cool down, okay, and then the piston scratch it out, and now you get a little piece of metal running around inside the cylinder, and then it causes the scuff wear. Okay, it causes the wear inside the cylinder surface, cylinder wall surface. Now, to prevent scuff wear, the top compression rings, okay, may be filled with molybdenum. Okay, molybdenum, okay, has a lot higher melting point than cast iron. This is double, right, almost double, okay, to prevent it from melting and create scuff wear, right? So it's coated with molybdenum. So this molybdenum in this picture is called molyfill cast iron. So that's the top one. Okay. The next piston ring is an oil control ring. Okay. The function of it is to scrape most of the lubricating oil on the cylinder wall so that it return to the crankcase. Okay. During operation, piston move up and down. There is a lubricating oil around the pistons. Okay. Now, when the piston moves down, it has to scrape the oil down to the crankcase under or the oil pan under the engines. Okay, if you do not scrape the oil down, oil gonna flow up into the combustion chamber, and you lost oil. and then you create pollution also, right? You lost the lubricating oil, which is not good, and then you create a lot of pollutions when you burn lubricating oil, right? Now, normally there is more than one piece of the oil control ring, okay? It has an expander and it has a plate. So the plate used to scrape the oil, the expander used to push the ring out, right? So the to do that you have to push the plate out so that the plate can scrape the oil. Okay, so that's about the pistons. Now, the valve trains. Okay, the valve trains. Okay, this is a picture of valve train. Okay, one type of valve train. This is overhead camshaft. So from the crankshaft, so you use this chain. Okay, the timing chain to drive the camshaft. Okay, and you drive both of the camshaft using these gears. Okay, and this camshaft and this camshaft spin. On the camshaft, you have this cam lobe that push the valves. Okay, push the valve down, push the valve stem, basically push the valve stem, this valve stem, to open the valve. Okay, when the nose or when the toe of the lobe pass the stem, okay, then the spring push the valve back to the closed positions. Okay, now first we talk about the camshaft timing. Camshaft timing is a relationship between camshaft and crankshaft. Okay, of course, piston is related to the crankshaft rotations. Valve is controlled by the camshaft rotations. Okay, so the piston is controlled by the crankshaft. The camshaft is so the valve is controlled by the camshaft. So of course, camshaft and crankshaft has to be synchronized somehow, because piston has to work with valves. Piston and valve has to work together. When the piston move up, the valve has to close, right? In the compression stroke, right? So uh, uh, these are the relationship between the camshaft and crankshaft. Now, the valve open only once for each cycle. The four-stroke cycle, the valve open once, intake once, and exhaust once, open once. Okay, during the whole cycle, intake, compress, power, and exhaust. Okay, valve open once, but the crankshaft turn twice. Okay, turn two times during one cycle, right? Intake, compress, one cycle, one round. Oh, sorry, one round, and then power and exhaust, the second round. So two round, but valve open once. Okay, which means okay, the ratio between of the speed between camshaft and crankshaft has to be 1 to 2. It has to be 1 to 2, right? Camshaft rotate once, crankshaft rotate twice, right? So the gear or sprocket of the camshaft has to be twice as large. Okay, this is double the size of the crankshaft sprocket. Okay, the camshaft sprocket has to be double the size of the crankshaft sprocket. So that's period. Okay. Now, not only the speed, you have to synchronize the position of the shaft also, right? So during the first, let's say during the first piston or the first cylinder, the piston in the first cylinder, okay, if it in the intake valve has to open, right? So you have to position these two shafts, right? Therefore, when before you can install the chain, the timing chain or timing belt, before you do that, you have to put the mark. Okay, you have to how do you say align the timing mark between the camshaft sprocket and the crankshaft sprocket like that. Okay, there has to be a mark that you have to align them before you put in the timing chain. So see, when you install it, you can turn camshaft and crankshaft freely, right? Before you put the chain, the timing chain in. Now, before that, you have to rotate it such that you align the timing mark, okay, before you put the timing chain. Install the timing chain. Okay. Now, some engine use timing chain, okay? Some engine use timing belt. Okay. Now, because this relation between crankshaft and camshaft, it has to be fixed. Okay. So you cannot have this chain, or sorry, this belt skip teeth. Okay. It cannot skip teeth. So that's why you have to control the tension of the belt or the tension of the chain. Okay, if the belt, okay, if it is the belt, you have to use this belt tensioner. Okay, next, okay, the valves. Okay, we have intake valve and exhaust valve. Okay, the valve look like this. Okay, the valve body, the valve stem, and the valve tip. Okay, we also have this groove for valve spring retainer lock. Okay, valve spring retainer lock. It is a retainer of the valve spring, and this rope groove is for the lock of the retainer. Okay, you have this called phase. Okay, normally intake valve is usually larger. Okay, because the pressure difference between the atmosphere and the vacuum inside the cylinder is small. Therefore, we need large valve so that the flow can go inside uh, easier. Okay, we don't need very large exhaust valve because exhaust gas has high pressure. Okay, so pressure difference is high, so it flow easily than the intake gas. Okay, now some valve, especially exhaust valve, okay, has a special feature of have a special cooling inside. Okay, this is important for the exhaust valve. Okay, normally uh, the exhaust gas, which is a hot gas, pass through the exhaust valve, and how the valve is cooling is there are three way or two ways. The first one is go to the valve seat. Okay, the heat flow to the valve seat, and then go to the coolant inside this cooling water jacket. Okay, and the other way is going up valve stem and go to this water jacket on the left and on the right. Okay, this valve seat go to this water jacket. So there are many water jacket inside the um, engine head. Okay, now because of that, the temperature is the highest at the middle of the valve body, and then it's getting lower and lower, and heat transfer out here, and it go up the stem. Okay, some valve has special feature. They have this sodium fill inside, okay, so that they use the motion of the valve, okay, to help transfer heat. Okay, this sodium can go up and down. It is a liquid inside the valve, so it's go up and down so that it help remove heat faster. The valve seat, okay, which is this guy, okay, in Thai เราเรียกบ่า valve, okay, and valve guide, which is this part, okay, ภาษาไทยเรียกปลอก valve, okay, bar valve and block valve. Okay, uh, they have two type. Okay, so it were the replaceable one and the integral one. Okay, integral mean it is the same piece as the engine head, or it is the same material or same piece, okay, as a engine head. Replaceable mean you can replace, of course. Okay, now this valve seat is a machine surface, okay, that valve face rests when it close. Okay, so basically it has to seal. Okay, it has to seal the combustion chamber. Valve guide, okay, this valve guide, okay, provide close fit of valve stem, such that we can control, okay, but not too fit, otherwise valve cannot move, right? And then we have the valve spring attachment. Okay, when you put in the valve, put valves in the cylinder head, okay, on top, okay, you have to put springs around the stem, and then you have to put the spring retainer on top of the spring. Actually, okay, before you can put this retainer, you have to compress the spring like that. Okay, this is a tools, okay, used to compress the spring. Okay, you have to compress the spring, and then you can put the retainer there. Okay, the retainer is where the spring sit. Okay, and then you have to lock the retainer using this valve key. Okay, or sometimes they call it split lock. Okay, valve key and split lock. Okay, ภาษาไทยบางทีเรียกเกือกม้า okay, here to lock at the valve groove. You see, no, say valve groove, spring lock groove. Okay, this groove. So you lock it there, and then you let go of the spring. Okay, so you remove the tool, let the spring push up, and then spring close the valve. Okay, the spring always close the valve. In some engine, okay, they also have this rocker arm. Okay, rocker arm transfer motion from camshaft or cam lobe to the valve stem. Okay, the cam lobe push the rocker arm push the valve, or sometimes the cam lobe push the push rod, and push rod push the rocker arm, and the rocker arm push the valve stem. Okay, so there are many types of rocker arm. Okay, it can have like shaft mouth, stud mouth, adjustable rocker arm, and this is pedestal mouth. Okay, if you use rocker arm, okay, there is one benefit, okay, which is you can create rocker arm ratio. Okay, rocker arm ratio is ratio between this side of the rocker arm and this side of the rocker arm. Okay, when you have this ratio more than one, okay, from the valve side to the cam lobe side. Okay, now basically your camshaft or cam lobe can be smaller because you can increase the ratio using this rocker arm ratio. Okay, increase the lift. Okay, increase the lift using the rocker arm ratio. Now, because when you have valve stem coming in from the bottom of the engine head, okay, to the top of the engine head, right? On engine head, we have to have lubricating oil, okay, to lubricate all of those valve train components. Okay, therefore we have to have this seal. Okay, ภาษาไทยเราเรียกหมวกวาล์ว okay, หมวกวาล์ว okay, valve cup seal. Okay, basically this seal the lubricating oil, so that the lubricating oil do not go inside the valve stem, okay, around the valve stem and go into the combustion chamber. If we go there, we lost oil, right? So that's one type of the valve seal, the valve stem seal. Okay, now one thing to consider is the valve stem. For the valve is the valve rotations. Okay. During operations, okay, every time the valve open and close, it has to rotate also. The valve has open and close, it has to rotate. The reason that it has to rotate is that because if it close at the same place, it can create the hot spot on the valve. Okay, because it's always hot. Okay, if there is any position that always hot, it's gonna be the same position every time, right? Therefore, we have to rotate the valve, okay, to even out the hot or the heated part of the valve, right? So, if you have a rocker arm, okay, the rocker arm contact with the valve stem is slightly offset. So this is a stem This is the rocker arm. You can offset it a little bit so that it creates a little moment to rotate the valve. Okay, in some engine can use a valve rotator. This is valve rotator. Okay, actually don't know how it works inside, but it has a metal ball. Okay, a metal ball inside that have like going up the stair every time. Okay. The next component is valve lifter. Okay, valve lifter is this guy, and this guy. Valve lifter. Sometimes it called tablet. Okay, bucket tablet. Okay, sometimes it's called this one called valve lifter. This one is called valve lifter. Basically, the valve lifter transmit cam lobe movement. Okay, so it's between the cam lobe and the valve train. Okay, to the push rod. Okay, in this case, it transfer the motion of the cam lobe to the push rod. This one cam lobe to the rocker arm. This one the cam lobe to valve stem. So basically, this lifter, okay, has to be on the cam lobe. Okay, so normally the surface, okay, this surface of the lifter is curved. Okay, it is curved a little bit, right, so that it stays on the cam lobe. Okay, and there are two types of valve lifter. The first one is mechanical, or we call it solid lifter. The other one is hydraulic lifter. Okay, for the mechanic lifter, so solid lifter, okay, it is just a solid cup. Okay, it's a solid cup. Okay, or sometimes it has roller inside. Now, the problem is a solid cup or solid lifter is that, okay, after you use engine for some time, okay, there are wear on the valve train, and that wear cause the valve train clearance to be larger and larger. The clearance between component, okay, the clearance between component can be larger and larger, which means that whenever cam lobe rotate, okay, the valve lift, okay, the valve opening or the valve lip is smaller and smaller and smaller. It gets smaller because the gap or the clearance is larger, right? Okay, the valve lip smaller. Therefore, if you use mechanical lifter, okay, during some time, let's say 50,000 kilometers or 100,000 kilometers, you have to open up the engine and adjust the valve train clearance using this feeler gauge. Or this is a feeler gauge, the tool that used to measure the gap between two components. So you insert the feeler gauge to check the clearance. Okay, so the valve train clearance has to be adjusted after a while. Okay, for service. Okay, not like modern engine. In modern engine, you don't have to adjust valve clearance. You don't have to open up the engine. You can continue using the engines. Okay, unless there's problem with the engines. Okay, this hydraulic valve lifter is basically it has two parts, and inside the two parts it has a hydraulic oil there, which is basically the lubricating oil. Okay, the lubricating oil coming from the oil gallery, which means the passage of the oil is going into this hydraulic lifter, and then it adjusts the clearance automatically. Okay, automatically adjusting the clearance. Okay, this means you don't have to adjust the valve. You don't need the valve train clearance adjustment. You don't have to open up the engines for service. Okay, now when you open and close the valve, okay, it's called, okay, the timing, the valve timing, okay, which means the location or the time that you open and close the valve. Okay, normally the valve timing is given in the degree, okay, in the degree, in terms of degrees, before or after top dead center or bottom dead center. Okay, for example, this is a diagram showing valve timing. Okay, so this is top dead center here. So when the piston moves down, the crankshaft rotate, right? So the crankshaft rotate like this, and then you get to the bottom dead center here, and then crankshaft rotate again, piston move up. So in this way, piston move up from bottom dead center to the top dead center. So this is the location of the top dead center, mean piston at the top, where this is the piston is at the bottom. And normally the intake valve open before the top dead center. Okay, so that after the exhaust gas go out, intake valve open, get ready. When the piston move down, so you get the intake. So you get the intake air or the intake mixture. So it open 12 degree before top dead center. Okay, some engine might be 14 degrees, some engine might have like 10 degree before top dead center, and then it keep open during the intake stroke until it close a while after the bottom dead center. So the intake valve close about 50 degree after the bottom dead center. So it keep waiting, okay, until the air coming in more. Okay, so the piston move up a little bit and then it close. After that, intake valve close, you go through the compression stroke, and then you go to the power stroke, and then at the end of power stroke, the exhaust valve open a little bit before the bottom dead center. But this is 47 degree before the bottom dead center. It open before that because exhaust gas has a lot of pressure, so they want to release the exhaust gas out. Okay, and then keep open until after top dead center, a little bit after dead center. In this picture is 21 degree after the top dead center. Okay, uh, yeah, during that time, okay, intake valve is already open, so there is valve overlap here. Okay, at the end of the exhaust stroke and at the beginning of the intake stroke, both valves are open. Okay, this is called valve overlap. Okay, we need that. Okay, such that we have can can remove as much exhaust as we can and intake as much air as we can. Okay, to control this, depending on your cam lobe and the valve train, design. Okay, in some car also have actually every new car. Okay, every new car. I don't know, from like 5 years ago or 10 years ago. Okay, now all new car have variable valve timing. Okay, variable valve timing means you can adjust the valve timing for different engine operations. Okay, basically different engine speed have different valve opening. Okay, or valve timing. Okay, you can do that. For Honda, they call it VTEC. Okay, VTEC. For Toyota, they call it BVTI. Okay, for Mitsubishi, they call it MyVec. So there are many names, but basically the concept is that they variable valve timing. The reason they do that is that, okay, as engine speed is going up, okay, if you open when engine is running fast, if you open at the same angle, okay, the time is very close, very short. Okay, the time of opening is very short because the piston move fast, right? When the piston move fast from opening here and close there, it moves too fast. So the duration is too short. Okay, during high speed, therefore, engine do not have like the actually engine power drop at high speed. Okay, to prevent that, okay, at high speed they adjust the valve timing. Okay, open a little bit earlier and close a little bit later. Okay, so that the duration or the second or millisecond is still the same, or it helps improve engine power. Okay, it increase engine power. Okay, there are many mechanisms. Okay, you can just search on the internet. The different company using different mechanism. Okay, this picture is Honda. Honda is the first company or the first manufacturer that make variable valve timing engines. Okay, they have different rocker arm. Okay, they have the big rocker arm in the middle, and they have small rocker arm on the left and right. Okay, during low speed they use small rocker arm. During high speed they use the big rocker arm. Okay, so that's the concept. But different company have different mechanism for variable valve timing. Okay, okay, so that's it for this chapter.